Good morning. This is graph theory part 2 for previous examination questions. If G is a connected planar graph with 14 regions, each of degree 4, find the number of vertices in G. To solve this, we use sum of degree theorem. That is, sigma degree of R is equal to twice the number of edges. Sigma degree of R equal to twice the number of edges. This means degree of R1 plus degree of R2 plus so on degree of R14 is equal to twice the number of edges. So given that each degree region is 4. So 4 plus 4 plus so on 4 is equal to twice the number of edges. That is 4 times 14 is equal to twice the number of edges. That implies number of edges is equal to 56 by 2, which is equal to 28. Now it is given planar graph. So by Euler's formula, number of vertices minus number of edges plus number of regions is equal to 2. So substitute the above values in this equation. Number of vertices minus number of edges is 28 plus number of regions is 14, which is equal to 2. By simplification, we can get number of vertices is equal to 16. So there ends the problem. Now define isomorphism. Two graphs G1 and G2 are isomorphic if there is a function f from v of G1 to v of G2 such that first one is f is 1 to 1, second one is f is on to, and third one preserves adjacency. Now we will check the given graphs whether isomorphic or not. Prove that two graphs are isomorphic. To check the isomorphism, first you check number of vertices in graph 1 and also number of vertices in graph 2. Here number of vertices in graph 1 is 4. So number of vertices equal to 4. Next number of vertices in graph 2 4. So therefore number of vertices in graph 1 is equal to number of vertices in graph 2. Now check number of edges. So here 1, 2, 3, 4. Number of edges in graph 1 is 4. Number of edges in graph 2 also 4. Therefore, number of edges in graph 1 is equal to number of edges in graph 2. Now find out degree of sequence. Here degree of a vertex A is 2 because there are two incident edges from A. So each vertex has a degree 2. That means vertex A is 2, B 2, C 2, D 2. So degree of sequence in increasing order is 2, 2, 2. And also find degree of sequence of graph 2. Graph 2 also each and every vertex has a degree 2. So P2, Q2, R2, S2. So that each degree has a each degree of vertex is 2. P, Q, R, S degree is 2. And we conclude that degree of sequence of first graph is equal to degree of sequence of second graph. Therefore, D1 equal to D2. Now define or check edge correspondence. Here edge G1 A comma C is corresponding to P comma R, and A comma B corresponding to P comma S. A comma B, edge A comma B corresponding to P comma S. B comma D corresponding to S comma Q. S comma 2. And edge C comma D corresponding to R comma Q. Now define A for P, B for S, and C for R, and D for Q. So f of A is P, f of B is S, f of C is R, f of D is Q. Now find out the adjacency of a matrix in graph 1, and also find out adjacency of graph 2. So by observation, adjacency matrix of graph 1 is equal to adjacency matrix of graph 2. Therefore F is 1 1 on 2 and preserves adjacency. Therefore the graphs G1 and G2 are isomorphic. Now prove the following graphs are isomorphic. So again, this is a bipartite graph. So number of vertices is equal to 6, and here it is a graph 2, number of vertices is 6. So number of vertices in graph 1 is equal to number of vertices in graph 2. First condition is over. And second, number of edges. So number of edges in a bipartite graph is m into n. So 3 into 3 is 9 edges. Here also 9. So number of edges in graph 1 is equal to number of edges in graph 2. Now find out degree of sequence. U1, U2, U3, U4, U5, U6 degrees are 3, 3, 3, 3, 3. All are having degree 3. So degree of sequence is all 3's. And also graph 2's degrees also same. Now check the edge correspondence between the edges. So according to this, we define that U1 goes to V1 and U2 goes to V4, U3 goes to V5, and U4 goes to V2, and U5 goes to V3, U5 goes to V5. No, U5 goes to V3. Yes. U6 goes to U6 goes to V6. And also observe that adjacency matrix of graph 1 is equal to adjacency matrix of graph 2. Therefore, G1 and G2 are isomorphic. Now determine whether the following graphs are isomorphic. So by observing that, check number of vertices in graph 1. We have u1, u2, u3, u4, u5. So number of vertices in graph 1 is 6. Also number of vertices in graph 2 is also 6. So number of vertex in graph 1 is equal to number of vertices in graph 2. First condition is over. Now check the number of edges. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of edges in graph 1 is 9. Again check number of edges in graph 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of edges in graph 1 is equal to number of edges in graph 2. Now check degree of sequence. Degree of u1. u1 degree is 1, 2, 3. So degree of u1 is 3. Degree of u2 is 1, 2, 3, 4. 4. And degree of u3 is 2. Degree of u4 is 3. Degree of u5 is 4. Degree of u6 is 2. And again check degree of v1. It contains 2. So degree of v1 is 2. Degree of v2 is 1, 2, 3, 4. So degree of v2 is 4. And the degree of v3 is 2. And degree of v4 is 1, 2, 3, 4. So degree of v4 is 4. And degree of v5 is 2. Degree of v6 is 1, 2, 3, 4. So degree of v6 is 4. We wrote here. And write in increasing order 2, 2, 3, 3, 4, 4. And also the degree of sequence of graph 2 is 2, 2, 2, 4, 4, 4. So observe that degree of sequence in graph 1 is not equal to degree of sequence in graph 2. Therefore, G1 comma G2 are not isomorphic. Thank you very much.